Hi, everybody. We'll be getting started in just 1 minute. Thanks for calling in. We'll wait just about another minute and then we'll get started with session 1. So thanks everybody for calling in and let us know where you're calling in from. Hi, Nicole. Good to see you here. All right, we'll go ahead and get started. So welcome everyone to our first session of our Introduction to Data Visualization in Observable Plot course. This is going to be an introductory course. So we're going to start with the very basics of building plots and charts and data viz in Observable Plot. And then each session will add a few more skills and a little bit more complexity with the goal of by the end of this course, you're able to, on your own, build custom data visualizations all by yourself. So really excited to be teaching this course. And we're going to start today with a little introduction and a few logistics. Then we're going to do a quick intro to notebooks and observable plot. Then we're going to get into a few of the concepts. So we're going to touch on the grammar of graphics and how we build things layer by layer. Then we're going to start building some fundamentals. So today we're going to talk about marks, channels, and scales. And then in future sessions, we're going to be talking about transforms and adding interactivity and further customization and different chart types. So my goal today is within the first 10 minutes that everyone has created at least 2 charts in Observable Plot. So that's ambitious, but I believe we can do it. And then we're going to keep doing hands-on activities throughout the day today. So first, I wanted to introduce our team that is here to support you. I am Allison. I'm a data scientist advocate at Observable. Really excited to be teaching this course. But we also have Robert, who is helping out in the background, who is there to answer your questions, which I'll share the different ways that you can post questions or share related to this course. And we also have Henna, who is helping run everything and organize all these sessions and has been sending the reminder emails and updates that you've been receiving. So we have a whole team here ready to help you out throughout this course. So a few logistics. If you have questions during this course, you're welcome to put them in the chat in the live stream that you see. So I'll be checking that and trying to respond to some of the questions. I might not get to all of them. Robert might respond to some of them before I get to them. Or if we haven't responded to everything by the end of the session, then we can also follow up and respond in the community Slack channel, which is the next recommended place where you can ask questions or have discussions. So Observable has a community Slack channel. We'll share the link for that, and you can go share there. You'll see there's a bunch of channels where you can have discussions, share what you've been building, ask questions, engage with the community. It's a really fun place to hang out with folks and learn more from what other people are doing and get help. So a couple of things for following along today. You do need to have an Observable account if you want to save your work from this course, which we highly recommend doing. So you can create an Observable account, and that'll allow you to fork the notebook that I'm going to be sharing so that you can create your own copy and then work there. So if you haven't already, make an Observable account. We'll share the link there where you can sign up for your own free account, and then you can follow along once I share the notebook. And I'll introduce Observable notebooks in case folks haven't worked in notebooks before. You may today, if you have two devices, you may want to have two screens side by side, or even if you're on a single device, you might want to set up two screens side by side because I'll be live coding, and that way you'll be able to watch what I'm doing while also following along and writing your own code. Throughout the day today, in the notebook that I'm going to share shortly, you'll see that in the follow along version, there are show me buttons in the notebook, and I'll highlight those when I switch over to the notebook too. So there are show me buttons, and if you click those buttons, it'll reveal the code that I'm typing, which hopefully helps everyone stay caught up. And if you get stuck from like a missing curly brace or something, hopefully you're able to then click the show me button. You can copy the example code there, and that'll get you back up to speed. And all of the code keys, slides, and recordings from this course will all be openly available, so you can return to them anytime. And if you miss anything, then you can go back and see all the materials from this course. So I'm going to switch over to the notebook that we're going to be working in. Because the first thing that we want to do is meet Observable Plot. So that's why you're all here, presumably, in this Data Viz and Observable Plot course. Observable Plot is a JavaScript library for Data Viz. It's built by the team that made D3, and it gives you a really fast way to create charts from your data while making it straightforward to customize and add interactivity to your data visualizations. So if you have been building data visualization with other tools, particularly those that follow the grammar of graphics, Observable Plot follows that same framework for building up data visualizations layer by layer. And if you haven't been building charts that way, we'll learn more about that in today's session. But it gives you versus D3, which gives you full control over what you create. So oftentimes data viz that are made with D3 are these very artisanal, bespoke, custom, beautiful visualizations. What that also means is when you're working in D3, you are building things up piece by piece from scratch. So a kind of standard chart, even like a scatterplot chart, might be 40 lines of code in D3. An observable plot just adds a layer of abstraction that allows you to start off a little bit closer to what you want to end up with for your data visualization. So we're not building things totally from scratch. We're starting at a little bit of a closer level to the final viz we want to create. And I wanted to highlight before we head over to the notebook, there is new observable plot documentation. There's an amazing gallery of examples in there that you can actually make copies of and then iterate on and tinker with. So check out, these are examples from the plot gallery, but there's also a really amazing new documentation site for Observable Plot where you can learn more about the library, see all of the different options, and see all of the examples. So highly recommend that as your go-to resource for Observable Plot information. Okay, let's hop over and make our first data visualizations. So what you're going to want to do is we're going to share the link to this follow along notebook. So this follow along notebook has links to the slides for today. It has links to the key for today, which has all of the code, but it also has some instructions for the different activities that we're going to do. And what you want to do is make your own copy of this notebook that you can work in. So when you go to that link, if you have your observable account and are logged in, then you should see this fork button up in the top right, and clicking that. So I'm going to go ahead and click that now. Clicking that, and you can choose, if you have different workspaces, you can choose where you want this to live. And if you click fork, then that's going to take you over into your own copy. So everyone go ahead and create your own fork of that follow along notebook. So it looks like the key was shared in the links, and there's also this follow along version that we can share with folks so that they have the buttons for the show me buttons. So you're going to want to fork the follow along version. And I'll give everybody a minute once that's posted. And what we're going to do next, while folks are waiting to fork the follow along version, I'm going to go ahead and talk through notebooks a little bit. So what you're looking at is an observable notebook. This, if you've worked in other observable notebooks, is a place where you can combine text and code and outputs in the same place. So when you're working in an observable notebook, you have all of your content added in different cells. Let me go ahead and share the follow along version in the chat. So I'll drop it in here. Okay, so there's the follow along version for this notebook that I'm in, and you can go ahead and fork that. So again, the way that you fork is you press that fork button, and that'll create your own copy. And so within an observable notebook, you add all of your content in different cells. You can add JavaScript cells, Markdown cells, HTML cells, or specialty cells. So each of those you can add by in the left-hand margin of the notebook, you click this insert cell button. So if you click that plus sign in the left margin, you can see this is where you have all of the different options for the different cell types you can add or different code snippets. So this is where we will be able to create our first visualizations in just a few minutes. So let's go ahead and try it. So this is our notebook. We can add cells by clicking that plus sign in the left margin between any two existing cells. Let's go ahead and make our first chart. So we're going to make a few things, run the code so that we can see the outputs, and then we're going to learn how to build custom charts. But if you click on this plus cell in that follow along notebook that you forked, so in your fork of the follow along notebook, notice that there's this search bar. So for example, if I start typing cell, I can see that there's an option for cell chart. So go ahead and navigate. I'll show that one more time. If I click on this add cell button and then search for cell chart, then when I select that, so I'll just click on that option, what happens here is a new JavaScript cell is inserted into my notebook, but it contains some pre-existing plot code using Observable Plot to create a heat map in this case. We're going to talk through what these different pieces mean. So if this looks overwhelming at this point, don't worry, because this is the kind of thing that we're going to learn throughout this course is what these different things are doing and the language around it. But we get these plot snippets, and then to execute this code, you can either press the play button in the top right of the cell, and that will execute the code, and it'll show up above that cell, the output. Or if you want to execute code with a shortcut, you can use shift return. So congratulations. You may have just created your first data visualization in Observable Plot. You might not know what this code does yet, but that's why you're here, is so that we actually can build things on our own and understand how we can create and customize our own visualizations. But just to give folks an opportunity to practice that process of adding a cell and then creating a code snippet and then running that code, I want to ask you all to do just an activity. Add a new cell. So open the add cell menu again by clicking that plus sign. Search for a chart type. Like if you just look for chart here, you can see there's a bunch of different selections in the add cell menu. Pick one. You'll see that a new JavaScript code chunk is inserted with pre-populated code, and then run that code to see the visualization that you've created. So I'll choose an area chart, for example, and then I will do the shift return shortcut, and I can see that an area chart is inserted. Okay, so this means that within, I guess we're 13 minutes in, if you've done this, if you followed along in your fork of this follow along notebook and are able to use that add cell menu and then choose a code snippet for different chart types, then you have already created your first two observable plot charts. What we probably want to do, though, is not use the existing built-in charts. And these, if you're wondering, like, where is this data coming from, Observable has within it built-in data sets. So that includes weather. So this is the weather data set and an Apple data set that contains data about Apple stock prices. So that's where those are coming from, but we're also going to learn throughout this course how you can attach your own data to create a visualization. Okay, so that's a little introduction and first activity, just as a little warm up to see an observable notebook. Hopefully everybody has their fort going. If you're having trouble, please post in the chat so we can get you up and running, or in the Slack channel so we can help you out. All right, now let's move on to the rest of this lesson. So we just saw that we can create visualizations using Observable Plot, but now we're going to back up because those snippets are automatically populated, but we might not know what each of those pieces mean, and we really want to understand what that code is actually doing and how we could customize and extend on it. So one thing that we're going to need to learn a little bit about is called the grammar of graphics. And the grammar of graphics, this is from Hadley Wickham's 2010 paper, A Layered Grammar of Graphics, which I highly recommend for anybody in data visualization or interested in it. A grammar of graphics is a tool that enables us to concisely describe the components of a graphic. Such a grammar allows us to move beyond name graphics, like the scatter plot, and gain insight into the deep structure that underlies statistical graphics. So this gives us language and a set of rules that we can use to define every piece of a data visualization. And once we can build that language and those rules around how those things are built, that gives us the control and skills that we need to be able to build up data visualizations layer by layer. So what are the layers of this layered grammar of graphics? You'll see this represented different ways, but this is kind of a standard representation of what the different layers of the grammar of graphics are. And the way this works is like layer one, like the base layer is at the bottom here. And then as you continue going up, those are kind of the layers that you would add on to information to describe the graphic. So the first layer is the data. So what is the data that you actually want to visually represent? The second layer up is the aesthetic mappings, and that's how are pieces of your data, like your variables, going to be represented in this visualization that you're going to be creating. Are they connected to the X and Y axis scales? Are they connected to a size of a dot? Are they connected to the opacity? So there are different ways that you can connect your data variables to the aesthetics that we actually see in a visualization. So that's the next thing that we need to tell our visualization is how are pieces from our data going to be connected to what we actually are representing in our data visualization. The third and a really important one is scales, because even once we have mapped our variables from our data to our chart aesthetics, we have to understand and define what those scales are. And we're going to talk more about what scales can be. It can be a quantitative scale, like the values across which we're representing a variable, or it can be something like a color or size scale that we're mapping our variables to. We also need to tell our visualization how our data is being represented. So that in some other tools, like in ggplot2, if there's any R users here, those are called geometries. We're going to use the language marks for observable plot. And that's just the geometric shape that we're using to represent the data. So maybe that's dots or lines or bars or cells or text, etc. So there's different marks that we can choose to represent the data. And then on top of that are several things that we're going to be getting to in future sessions. Like, are we transforming data by binning it and finding mean values, for example? Are we faceting it to have a different panel for different categories? And are we using a different coordinate system? So are we viewing this on a Cartesian coordinate system, or are we viewing this, for example, on a polar coordinate system? But these are the basic levels of creating data visualizations in Observable Plot. So I want to back up now and look at kind of a minimum viable example of Observable Plot code and talk through this a bit. So in Observable Plot, what you'll usually see, although you can see this written different ways, but this is the most common way you'll see Observable Plot code written. You'll usually see this initial piece of code, plot.plot, and that is initializing the plot. That's essentially saying like, hey, heads up, I'm making a data visualization with Observable Plot. Whatever comes next, that's going to be layered onto that visualization. So that's initializing the plot. And then within that, we will have a section for the different marks. And as a reminder, marks are the geometric shapes that we're using to represent our data. So in this example, we only have one mark, and that's the plot dot dot mark. So this is a dot mark. This is by default going to put for each variable that's mapped to the X and Y scale. If you have X and Y, you might only have X here, for example, if you're doing like a rain cloud plot or a jitter plot. This is going to place a dot representing the data. But there's also other marks, plot.line, plot.bar, plot.text. So there's many different marks built into plot. And within that geometry or mark, within that plot dot mark, the first argument is the data. And then following that, we have these aesthetic mappings. In this case, saying that we're going to have along the x-axis scale, we are going to plot the values of that horsepower variable. And on the y-axis scale, we are going to be plotting economy in miles per gallon. And thinking about this aligning to the grammar of graphics, that base layer data, that's cars in this case, a built-in data set cars. The aesthetic mappings are where we define what X and Y are. And the geometry is plot dot dot. And then by default, there are selected scales, but we can change those like we'll see later today. So the scales are created by default for us, like the extents and increments for X and Y on a linear scale. And this also doesn't have any statistics or transforms or faceting. And the coordinate system by default is a Cartesian coordinate system. So we really, even in this like minimum viable example, have a lot of different components of the grammar of graphics represented. So let's go ahead and check out another example in Activity 2, where we explore a little bit more deeply the grammar of graphics in Observable Plot. So I'm going to hop back over to my notebook for session 1, and I'm going to scroll down to Activity 2. So you all can follow along. I'm down at Activity 2. And this one is going to be a little bit different than what we did previously. In Activity 1, just as a warm-up and to familiarize ourselves a bit with notebooks, we had just added a code snippet from the Add Cell menu for a chart type that we selected, and then we executed that code, and it runs using a built-in data set. But we're going to do something a little bit different here. In this example, what we're going to do is we're still going to start with a code snippet, but what we're going to do is actually replace the built-in data and the default aesthetic mappings with some aesthetic mappings that we choose. And I'll talk through how these relate to the grammar of graphics once we've created that visualization. But one thing to notice here is that there in this notebook that you forked is an attached file. So this is one way that you can get your data into observable notebooks, is you can drop a file like a CSV or an Excel workbook or some other file type. There's other ways you can connect data to your observable notebook, including connecting to databases. But in this case, I just dropped a CSV into this notebook and it's attached. And then I have this line of code that actually attaches or loads that file for use in my notebook. And this is stored as energy. So keep that in mind because we're going to need to tell our observable plot code what the data is. So the energy data, as a preview, looks like this. So the energy data comes from the US Energy Information Administration, and it contains information for energy production in quadrillion BTUs over years from 1973 to 2022 for different energy types. So you can see if you scroll along in this data table cell, you can see that it reveals the different energy types like geothermal, crude oil, wind energy, etc. So what we want to do is we're working towards building a custom visualization that shows energy production over time for these different sources. As a starting point, what we're going to do is we are going to create a scatter plot. This may be ill-advised, but we are going to do this just as an example of how we can start building things with the grammar of graphics. So that's what our data looks like. The important things that we're going to need to remember are the name of the data, so that's called energy, and the name of the variables, because these are going to need to match exactly. So I have a type property that tells me the energy type produced. I have the year property, that's just the numeric year, and I have quadrillion BTU, this numeric value for the amount produced. So we need to remember those names because we're going to use those in this new chart that we create. So let's go ahead and make this scatter plot. And again, as a reminder, if you get stuck at any point, what I'm going to be doing appears in this show me button. You can expand it, you can see the actual code, and you can see the expected output. So again, as a reminder here, I'm going to click on in the left margin, the add cell menu. I'm going to start typing scatter plot. And when I select that, you'll see what shows up is a code snippet for a observable plot chart that uses the dot mark. So I see here, this is plot dot dot. But what I see here, like we saw in the example in the slides, is that this is actually using the built-in CARS data set, which for those of you who've been working in data science and analysis for a long time are probably very familiar with. But within this CARS data set, there's these two variables, horsepower and economy. So when I execute this functional code, then what I see is a scatter plot showing the negative relationship between car horsepower and gas mileage. But we don't want to create a visualization of car relationships. We want to plot something about energy. So let's go ahead and replace what we see here. I'll make this a little bigger in case that's helpful. What we want to see here is instead, I'm going to go ahead. There we go. So what I'm going to do is just swap out this data and variables, this data and aesthetic mappings with those that are appropriate for my data set. So the first one that I'm going to do is I'm going to replace cars with energy. So that's my data source. That's that bottom level in the grammar of graphics. The second level in the grammar of graphics is aesthetic mappings. So what visual aspects of my data visualization are my variables connected to? And in this case, I'm going to replace this horsepower on the x-axis, which doesn't exist in energy, with the year variable. And on the y-axis, I'm going to replace that economy and PG with that quadrillion BTU value. And now once I've done this, now I can see that I, instead of having a scatter plot of car, horsepower and economy, now I have a scatter plot of energy production in quadrillion BTU over years. Now, one thing that might make a lot of sense for us to ask is, well, I think it would be really important to actually be able to distinguish between these different energy types, right? There's clearly these different series. The cool thing, and I also might want to try a different mark, right? So you might think to yourself, like, what might be a better way to actually represent these trends in energy production over time? And a cool thing about creating visualizations in code and in the grammar of graphics is that it makes it pretty quick to swap out different marks to test different visualizations. So for example, here, if I was like, ooh, you know what? Actually, I think a line chart makes more sense, then I can just change that mark. And now I see that I have a line chart. So I swap that out, but something unexpected and unwanted happens here. And what's going on here is that this plot code has no information that there is another variable that may be important to it when creating this visualization. And that important variable that it doesn't recognize, because we haven't given it any information, is it doesn't recognize that there's an important variable called type that would distinguish that these are actually different series. They're not all connected, which is why we see these interconnecting lines that make this a nightmare. We have these different series that exist with the variable within the variable called type. So one way that you can tell observable plot that there's this other variable that needs to be recognized is you can use a Z channel and let it know what the variable is that things should be essentially grouped by. Like, these are my different series. So that is one example of how we can not only, again, add a code snippet from the add cell menu that uses observable plot, but we also have set the data, so bottom level of the grammar of graphics. We've set the aesthetic mappings here with X, Y, and Z, where X and Y are the variables that are getting mapped onto the X and Y axis scales. Z is the variable that it's recognizing groups within. So these are now individual series that are created. And then next, what we're going to learn is how we can start customizing this. Because looking at this, hopefully everyone is like, this does not have all the information that I need to actually interpret what's going on here, right? Like, we don't know what series is coal and what series is biomass and what series is wind energy. And that would be really great if we could distinguish between those things and do a little bit more customization. So that's what we're going to do next. But this is an example that I hope highlights kind of how we can start with a snippet, but then swap out either the marks or the data and the aesthetic mappings to create something new with data that we've attached to a notebook. So let's go ahead and feel free to post questions. If you have questions in the chat, I'll be keeping an eye on those. And I'm going to switch back over to my slides to introduce marks, channels, and scales. And we'll return to the language of the grammar of graphics throughout these sessions as we kind of focus on those different layers. But now for the rest of this session, I want to talk about marks, channels, and scales. These are some kind of essential pieces of building visualizations in Observable Plot. So once we have built our base plot, we usually want to start customizing it. So like I said, with that line chart of energy, like, sure, we've swapped out the data and the variables, but it still doesn't have the information that we need to be able to interpret something meaningfully. So we're going to learn a little bit more in this section about marks, channels, and scales to both build language around those things, but also learn how we can actually update those in plot code to make custom and understandable, meaningful charts. So what are marks? This link sends you to that marks link right at the top, sends you to the marks section of the Observable Plot documentation. And you can think of marks as a visual vocabulary, a painter's palette to create your data visualization, but that uses shapes instead of colors that you pull from when composing a chart. So instead of thinking like, I'm going to put my paintbrush in this yellow paint and then that's going to go on my canvas, instead we're saying, I am going to pull this dot mark and those are going to be placed on my canvas. Each mark produces a certain type of geometric shape, like dots, lines, bars, cells, text, etc. And marks take two arguments, the data and options. So we actually have already seen that within a mark like plot dot or plot line, we need to tell it the data that it's using. And we've also provided it with a few aesthetic mappings, but we're going to extend the options that we can actually use to customize that. We use marks instead of specific chart types, which can really allow you to be more efficient and flexible in terms of the variety of data visualizations that you can create, while also saving a lot of brain space. So what do I mean by that? Because I think this idea of using marks for folks who maybe haven't worked with the grammar of graphics before, it can be a little bit unsettling. Like if you're used to working with tools where it's just like, no, I'm just making a scatter plot, so tell me it's a scatter plot, or I'm just making a time series plot, give me the time series plot option. But instead, we're backing this up one level to say like, that's a dot mark that's used to create a scatter plot, but what we're telling the plot code is just the dot mark information. So why can this really be valuable? Well, this, like I was saying, allows you to keep fewer things in your memory while expanding the number of different types of visualizations that you can create with that knowledge. So for example, plot dot dot, right? That's one mark, but that can make many, many, many different types of data visualizations. For example, with the dot mark, you can make a scatter plot. But you can also make a stacked dot plot like this orange and blue one in the top right. You could make a bubble map, which we will be doing later on in this course, where different locations, different attributes determine the size of the dot mark. You can make jitter plots, rain cloud plots. You can make lollipop or Cleveland dot plots. And that's all using the same mark. So once we shift over to this framework for using marks to add geometries to our canvas, instead of being beholden to the thousands of different individual chart types, then we have a lot of flexibility with what we can create using those marks. So we have control over the type of chart that comes out of it by specifying and then customizing that mark. So that's marks. So marks are geometric shapes that we're using to represent our data in our data visualization. But within marks, there are options. So remember, the two things that marks need is data and options. And there are two different ways that those options can be represented. They can either be a constant. For example, if you set an option for a dot mark that is the fill color is red, that's a constant value that those are being set to. That means all of your points are going to show up as red. But you're also going to hear this language called channels, and you'll see that throughout observable plot documentation. And channels are mark options that are used to encode data that gives you options that vary with the data. So for example, those are options where you can put data at a different location or give it a different color or give it a different size, for example, based on values in the data. So in summary, if an option value is changing based on a variable value, we refer to that as a channel. And if an option value is set to a constant, then those are just called constants. And we're going to see both of those, and we're going to play with both of those in our next activities. So those are channels. So those are options for our marks that change or encoded based on the data. And the last thing that we're going to highlight in this next section are scales, because even once we have connected our data to some option or some channel, even once we've done that, we need to provide a scale that lets us know, like, well, how is my data mapped on to that aesthetic thing? Like, and that could be, for example, position. Like, is this a linear scale that only ranges from the minimum to the maximum of my quantitative variable for the x-axis? Or is it a logarithmic scale that extends to far beyond either of those? So scales can help us convert that abstract measurement in our data onto a visual value that's represented in our visualization. Another example could be color, like how, for example, can I map a species of penguins, and this is an example that we'll do, where species are represented by different colors, and how can I control what that color scale is? So we tend to think of scales as quantitative ranges of things, but we'll talk about scales more generally. So scales are how we are mapping our data values onto these different visual representations, whether that's the position or the color or the size of the mark that we're creating. So two things, and this is something that I always have to remind myself of, is scales are defined by their domain. Those are the input values coming in from the data. The only way that I remember this is that domain has the word in it. Otherwise, I mix these up. So domain is the information coming in from the data. And then the range of a scale is the output. Those are the visual values that the scale generates as an output in your visualization. So as an example that we're going to see in our next activities, an input from our data might be the types of energy that exist in a data set. So those would be all the different categories of energy that exist in the data set. Those are my inputs for a scale. And an output, the range, might be a different color for each of those different categories. So that's one example of a scale that we could customize. And we'll see how we can both update and customize these for a couple of different channels in Observable Plot. All right, so now we're going to hop back to our observable notebook for activities 3 and 4, where we're going to do some customization with marks, channels, and scales. And we're going to be in the notebook for the rest of today's session. So hop back over to my notebook and scroll down to activity 3. And we're going to play around with some customization here. We're going to do some things, and I encourage you to just try things, like try and break things. You have the show me code right there. You have the key available. I encourage you to try playing around with different marks and layers and customization. But what I'm going to show in this example is something that builds on the previous line chart that we made, but then customizes it in a number of ways, both with constant options and with channels. So with aesthetics that are varying based on my data values. And we'll also play around a little bit with a couple other options that can be applied globally to my data visualization. So let's go ahead. And again, once I'm in my notebook, I can insert a new cell with this add cell menu. I'll click insert cell. And I, in this case, am just going to start with a line chart. So I have searched for line within that add cell menu. You can see there's a bunch of different options for even lines. You can have moving averages with different windows. You can have linear regression, for example. But I'm just going to choose this basic line chart, and then we're going to customize it. So again, this pre-populates with some existing data, that Apple time series data, but we're going to go ahead and customize this for our purposes, which again uses the energy data that's already in your notebook. And I'm going to have year on the x-axis, and on the y-axis, I'm going to have that quadrillion BTU again. So one thing that's really cool is that we already saw that you can add that Z channel, which will distinguish the different series. But another way that you can distinguish series is by adding a separate channel that's going to give each of these different energy types a different stroke color. So if you're using other tools, just a heads up, sometimes this is called color. In Observable, a line color is the stroke option. So here, as another, and notice that I'm within my curly braces where I'm defining my options for that line chart. I'm going to have stroke, and then I'm going to give it the variable that I want this to vary by. Now, here's a place where we could see that like this could be a constant. So I could say stroke red, and that's a constant. So that's just a constant option. And I could still have Z and then say have this vary by type. One little cool tip for working an observable plot is you can use, you might have noticed that my code automatically formatted into this nice vertical structure with shorter lines, which I really like. You can use Option Shift F, and that will auto format your code within a JavaScript cell to have this nicer format. So in this case, what I did is I set a constant for the stroke option, and then I still have this Z channel. But that's not really helping me out either. But instead of doing those things, I could actually make stroke a channel, meaning I can make stroke actually depend on a variable instead. And that's going to kind of get me a 2-for-1. So if here I use stroke type, notice that I don't have Z, but these different series are still recognized. And each of these different series has a different color assigned to it. So this is a channel because the stroke option is changing based on a variable value. In this case, the different categories within that type property. Just as a little fun win, one thing that was relatively recently added to Observable Plot are built-in tooltips. So we're going to get into, in sessions 3 and 4, we're going to get into more interactivity. But if you want to instantly make your chart interactive, you can add another option, tip true. And what that's going to do is it's automatically for any existing channels in your data. In this case, we have channels for year, quadrillion BTU, and type. It will automatically create this really nice interactive tooltip that shows up on hover for you. So that's a nice way to get quick interactivity. Okay, so let's do a little bit more customization, thinking about the grammar of graphics and marks and scales. So let's go ahead and see that we can also layer marks, because oftentimes you won't just want to have a single mark type. Maybe you'll want to have like a contour plot to show densities behind a dot mark that shows the actual locations of values, for example. So it's pretty common that you might want to combine marks. And just as a proof of concept to show how you would do that, you can go ahead and add that just within your marks. Notice here what's interesting is that we actually have this plot rule, and that's what's making this horizontal line on the x-axis. So we actually already have multiple marks within this observable plot code. But just to see that we can layer marks, let's go ahead and add another one. This is still within my marks section, right? This is still within those square brackets bounded by marks here. And my different marks that I add are separated by commas. So I'm going to do a comma, and then I'm going to add on top of this, I'll add a dot mark. So you could do this a different way, but I'm going to do this way just to show how this would work. So I'm adding a dot mark. Again, and marks need two things. They need the data and they need the options. And for us, those first options are going to be those aesthetic mappings for the X and Y channels. Where here, those are going to be the same as they are in the layer above for X year and for Y quadrillion BTU. And I'll see that when I add those, that those now show up as points across my lines. But I could continue customizing this. So I could say for that dot mark, I want the stroke to be white. So that's a constant option. But I want the fill to also be based on the type. And now we have this line chart with dots at each of the recorded observation locations, which are each of those 1-year increments. So this is just an example of how you can layer compatible marks into the same space and really start adding complexity and visual interest to your data visualizations. Okay, so now what I want to do, so we've seen marks, we've added visualizations that have multiple marks. We have added channels, right? So we've added options for marks that vary based on a variable in the data. And we've also added constant options, like in this case, stroke white is a constant option. Now let's do an example where we update scales, because that was the last thing that I talked about in the slides, was how we can change scales. Keeping in mind that when we customize scales from default settings, when we customize scales, we're going to say what the input is, that's the domain, and we're going to say what the output is, and that's what's visually going to show up in our chart representing those inputs. So I am going to go ahead and scroll down to activity 4. We're going to switch over to the penguins data set. This is a data set that was collected by Dr. Kristen Gorman in the Palmer Archipelago in Antarctica, and it contains observations for body size measurements for 3 different species of penguins. This is a built-in data set in Observable, which is why we don't see another file attached for penguins. It's already showing up. So let's go ahead and create a basic scatter plot. So actually, I'm going to ask you all to do that. I'm going to give you a minute, and I'm going to tell you the variables are actually shown here. The data is called penguins. And on the x-axis, plot flipper length in millimeters. And on the y-axis, plot body mass in grams. And those are the actual variable names. So you could even copy and paste those variable names. So go ahead and just do this first part, and then we'll do the rest of this together where we update the scales. So I'll give everyone a minute to go ahead and add that scatter plot from the add cell menu, and then just update with the penguins data and variables for X and Y. Okay, so I'm going to get started with this example. So I'm going to start by creating this scatter plot where instead of cars, I have data called penguins. Instead of X, I'm going to have flipper length in millimeters, and instead of Y, I'm going to have body mass in grams. Just running that code using Shift-Enter, I can see that this scatter plot is created. As a couple of other things that we might want to change, let's add a fill channel so that fill color changes based on species. And let's add a R channel, which is how we determine size, the radius of the geometric marks, so that varies based on flipper length. So I'm going to say fill color should change based on species. And if I do that, I can see that now this changes based on species. And I'm going to say I want the size with the R channel should be based on flipper length millimeters. So you might notice, right, that this flipper length variable, this channel that I've created for R, we don't really see a big size difference. But if you look closely, there actually is a difference in size. It's just really small. Like the circle size for this lowest flipper length down here is not that much smaller than the circle size for the largest flipper length up here. Sorry, I'm on the wrong axis, on the x-axis. So this is our smallest flipper length. This is our greatest flipper length. And there's only a very, very small difference between those 2 points in terms of the point's radius. So this is an example where we might want to update the scales. I also might want to change the color scale. Right now, the default color scale for these different penguins, and I can show that by saying in the color scale, I'm going to add a legend. So that's how I add a legend here. And then if you look above the chart, you'll see Adelie, Chinstrap, and Gentoo shown as the 3 species. But I might want to change what that color scale is. Again, we usually think of scales as quantitative things, but scales can apply to geometric shaped sizes. They can apply to colors that categories are mapped onto. So we're going to change both of these scales as this example. So here what I'm going to do, and notice that this is outside of those square brackets for marks. So I'm updating my scales outside of that mark section. I'm going to first update my scale for that size, and that's the R channel, right? It's angry because I don't have a comma after this yet, but I will. So I'm going to update my R channel scale by giving it a new domain and range. Remember, domain is what's going in, and the range is what's coming out. So here, I'm going to say, this now I have curly braces, the domain, I want to be the extent of my values within that flipper variable. And this is going to take a little bit of JavaScript's code. So I'm going to say, give me an array that goes from the minimum value to the maximum value. I'm going to do that using a D3 method called D3 extent. That's its job, is to return the minimum maximum value from the penguins data set. But I need to tell it what property I'm accessing those values from to find the minimum and maximum. And the way we do that is with a little accessor function that looks like this, where I'm accessing the flipper length millimeters value from the penguins data flipper length property. So that's going to return a minimum and maximum value for that property. So that's the inputs into this R scale, is the extent from minimum to maximum of that flipper length. And then we can say what we want the output to be. And that's what we're going to see visually for this R scale. So I'm going to say, still within this R scale, where I'm defining the options for this R scale, now I'm going to say range, and then I'm going to give it an array of values to range from. And I'm going to say range from 1 to 10. And now I can see that the range of sizes, the range of radiuses over which these values are represented is much larger than the scale was initially. Initially, there was a much narrower scale by default for R that I have just expanded, which is why we see this more exaggerated change in the size representation based on flipper length. So that's an example of using the range to represent updating a size scale for R by giving it an input value and then giving it an output value for the range. And as one final example, let's update the color scheme. So again, we're going to give it a domain which is an input. In this case, color is based on species here. So we're going to give it the inputs. Those are our different species names. So I'm going to say domain, and then I'm going to write this out. I'm going to give it the different names. You could do this programmatically. Chinstrap and Gentoo. These are the 3 penguin species in that data set. If I run this, nothing has changed because I haven't changed the range, which is going to update the output. But the range, the output of that color scale, now I can change that, giving it some web recognized color names for each of those different species. And once I give it that new range, then I can see that that color scale has changed. So we update our custom color schemes by updating the color scale, giving it the input values, in this case for a categorical value of species, and then we can give it the new outputs in that range for the color scale. So those are 2 examples of how we can update scales, but you have a lot of control over this. You can update the quantitative scales represented on axes. You can you can change the type of scale. For example, here I'll do it for the x-axis value. I can change this to type log, and then you can't really tell because there's not much of a span of data, but this x-axis is now on a log scale converted from the default linear. So within these different scales, you can specify both the domain and range and type of scale that you want to represent your data. Okay, so I'm going to head back because that hour goes by quick. We are at the end of time. Thank you all so much for calling in. In the next session, we're going to continue with customization with scales, but we're also going to get into transforms. So things like binning data, finding aggregate information like summary statistics and plotting those all within Observable Plot. Because while you could do a lot of that work outside of Plot, Observable Plot also has a lot of methods built into it that allow you to do that kind of all in-house, which is really, really nice for creating visualizations. So thanks everybody for calling in. Make sure to join the Slack channel. If your questions were not answered here, we will respond to them in the Slack channel. And we'll see you all in the next session in 2 days on Thursday. So take care, everybody. Thanks for calling in.